All right, 5.3, we're going to solve some trig equations in this section. So what we're going to do is we're going to solve algebra problems, only these algebra problems happen to have trigs equations in them, or trig identities in them, things like sines and cosines and tangents. So you're definitely going to want to have your unit circle out in front of you. We're going to try to solve problems like this. 2 sine x equals 1. All right, so we're trying to get x by itself. Normal thing that we do here is we would divide by 2. Sine x equals a half. And we remember that to get x by itself, we're going to do inverse sine on both sides. And we'll end up with x is the inverse sine of 1/2. All right, we go to our unit circle, and we're going to figure out all of the places on the unit circle where the y value, because it's sine, equals 1/2. All right, and we're going to put all our answers to these in radians. All right, so unless otherwise indicated, we're using radians when we're solving for trig equations. All right, so there's 1 at pi over 6, and there's another solution if we look over on the other side in quadrant 2 at 5 pi over 6. 2 places on the unit circle where the y value is positive 1/2, and that positive is important, right? Negative 1/2 is different than positive 1/2. Right? There's the other spot on the other side. Pi over 6 and 5 pi over 6. But remember, we could spin around the circle and land in the same spot. So if we wanted to, we could say, let's add another 2 pi on there. And if we wanted to, we could spin around again. So we could add a 4 pi, or a 6 pi, or an 8 pi, or a 10 pi, or any multiple of 2. So the way we write that is plus 2 pi n. N being how many more times are we going to go around the circle. Maybe it's no more times. Maybe n would be 0. But we're allowing for the fact that we could just go around the circle as many times as we wanted and still land in the same spot. Okay, so that would be our 2 solutions. All right, so I think it's going to be very helpful for you to have this trig table down. This is kind of the breakdown from the unit circle of all the important points. The sine of 30 degrees is 1/2. The sine of pi over 6 is 1/2. Right, so pause the video for a few minutes, copy this down, and I think it would also be helpful to add some categories here for cosecant, secant, and cotangent. I would fill those out if I were you as well. See if you could flip these over and rationalize your denominators. If you flip root 3 over 2 over, you get 2 over root 3, but clean that up. Don't leave root 3 in the denominator. So pause the video, take a few minutes, get that down. When you're ready, that's going to speed up these problems as we move forward. All right, here we go. So example 1, we want to collect like terms. We're going to solve like we normally would an algebra problem until you get the trig functions by themselves. So we add sine to both sides. We subtract the root 2. We divide by 2. Sine x equals negative root 2 over 2. X is the inverse of negative root 2 over 2. We're going to find all the places that we have a negative root 2 over 2 for sine. That's 5 pi over 4. And that is also 7 pi over 4 on the unit circle. And this didn't say where. It didn't say we couldn't spin around more if we wanted to. So we're going to put that plus 2 pi n on both of these. All right, so again, get the trig function by itself, and then get x by itself by using the inverse, and then look on your unit circle to solve. Try problem 11. When you're ready, press play, and the solution will show up. All right. Now, what do we do if we've got square roots? Let's solve this one. So we're going to add 1. 3 tan squared x equals 1. We're going to divide by 3. Tan squared x equals a third. And then we're going to square root to get tan by itself. So now we've got tan x equals square root of 1 over 3. That's the same thing as root 3 over 3. And that should look familiar from your trig table. X is the inverse tan of root 3 over 3. And so we've got 2 places on the unit circle where that is true, and those places are pi over 6 the other place that that is true is 5 pi over 6. Because when you square roots, it's a plus or minus. Okay, so be careful with that. We're going to get two separate solutions here when we do a plus or minus. Okay, now be careful here. Not 2 pi, just pi n. Remember the period for tangent and cotangent is just 1 pi. Not 2 pi, just 1 pi for tangent and cotangent. All right? So really there's 4 places on the unit circle where the tangent is either positive or negative root 3 over 3. Your turn on 15. Okay, so sometimes we're going to have two separate types of trig functions, in this example cotangent and cosine. And so our job is to get 0 on one side and then factor, just like we normally would. So let's subtract 2 cotangent x, so we get everything on one side. Now, be careful here. You've got to write it as a separate term, because this term is a cotangent and a cosine squared, not a like term with just regular cotangent. Okay, but that does leave us with 0 on the other side. And now, we do have a cotangent in both of these terms. We can pull that out. We can factor that out. Cotangent x, cosine squared x minus 2 is what we're left with. And then we're going to solve this just like we normally would with zeros. We've got two different problems to solve. Cotangent x equals 0. Cosine squared x minus 2 equals 0. Or cosine squared x equals 2, or cosine equals plus or minus square root of 2. All right, now let's look at the cosine first. That's the easy one. Remember that sine and cosine both need to be, sorry, the inverses of those, both need to be in between, well, let's just say it this way. -1 and 1, right? Because sine and cosine are either adjacent over hypotenuse or opposite over hypotenuse, and if you're a fraction bigger than 1, that means that the adjacent or the opposite is bigger than the hypotenuse, and that can't be true ever. So root 2 is bigger than 1. We've got no solutions from this one. Cosine cannot be the square root of 2. Let's go back and look at cotangent. Okay, cotangent wasn't on our trig table. Tangent is, though. We could say, what's the tangent when we're undefined? Because 0 flipped over is undefined. So when do we have x equal to the inverse tan of undefined? If we take a look on our unit circle, where is the x value going to be 0 to make this undefined? All right, and there's just one place going to be pi over 2. Okay? And on this one, we can say plus pi n to get the second option. 3 pi over 2 is also going to give you undefined, but we can get that with the plus pi n because we need to get every single answer. Remember, it doesn't say where. It doesn't give you restrictions in the problem. So we need to have that plus pi n at the end. All right? All right, 19 is your problem to try. Pause the video, give that a shot. When you're ready, press play for the solution. Okay, so what about quadratics? We're going to solve those just like we normally would. We're going to factor if we can. If not, we're going to use the quadratic. All right? So on this one, 2 sine squared x minus sine x minus 1, it might be helpful to do something like this. Use a instead of sine squared. Minus a minus 1. See if you can factor that. That'd be a 2a, a 1, an a 1, and our negative is going to have to be over here and here. But remember that it's really sine and not a. So this is going to be sine of x equals -1/2. Sine of, because this was equal to 0, sine of x equals 1, right? We're using the method of solving the zeros. And so we look on our unit circle. We're going to find all of those answers. So we ask ourselves, where is the y value equal to negative 1/2 on the unit circle? It is at 7 pi over 6. There's another one at 11 pi over 6. All right, and then we say, okay, when is sine equal to 1? Well, that's happening at pi over 2. All right. Now, we don't have to say plus 2 pi m because it says just in the interval 0 to 2 pi. That means just the first time around the circle, right? So the first time around the circle, there's 3 places that are going to work out for this equation. And those are your 3 answers. All right? Your turn with 33. Okay, example 5, we're going to do the same thing. Let's see if we can rewrite this. I know it's going to be 2 sine. I know it's going to be sine. And let's see if this is going to work out. We would have a one and a 3. Oh, I'm sorry, I'm looking at the wrong problem. And I see the problem here. Problem is that it's not sine and sine, it's sine and cos, right? Sine squared with cos. So that's a problem. So we need to get the same trig function going here. We're going to use our Pythagorean identities. We know that sine squared is the same as 1 minus cosine squared. So we could sub that in. Plus your 3 cos minus 3. So now we've got 2 minus 2 cosine squared x plus 3 cosine x minus 3 all equals 0. Let's clean this up. Negative 2 cosine squared x plus 3 cosine x minus 1 now, right? And so we can move these all to the other side and change the signs. Get 2 cosine squared x minus 3 cos x plus 1 equals 0. Did I make any mistakes there? I don't think so. Nope, that looks good. So now we can factor it. 2 cos and 1 cos and 1. Which one's positive, which one's negative? They are both going to be negative. All right, so cosine x equals 1/2. Cosine x equals 1. You look on your unit circle, where does cosine x equal 1/2? Cosine x equals 1/2 at pi over 3 and 5 pi over 3. You look on your unit circle, where does cosine equal 1? And that's going to happen at 0 degrees or 2 pi. The first one is 0. No restrictions up here, so we got to put the plus 2 pi n on each term. Okay. Your turn on 35. Okay, let's square and convert to quadratic type. So we've got cosine x plus 1 equals sine x. That doesn't help us, and there's nothing we can do with the quadratic or with the Pythagoreans to change this. So what we're going to have to do here is square both sides. Cosine x plus 1 squared gives us cosine squared x plus 2 cosine x plus 1. Sine squared x, that doesn't help us because we need cosines. So sine squared, let's convert it right away to 1 minus cosine squared x. All right, we'll bring this over. Now we're going to have 2 cosine squareds on the left plus 2 regular cosine x. And we're going to have minus 1, so that gives us nothing. Okay, so now we're in business here. And so on this one, can we factor anything out? Okay, we can pull the 2 and the cosine out. Cosine x plus 1 equals 0. So cosine equals 0, or it equals -1/2. negative 1, we look on the unit circle and say what value of x gives us a cosine value of 0 or negative 1, and our answers to that are going to be pi over 2. They're going to be 3 pi over 2. Those are the two places where on the unit circle the x value is 0. And then where is the x value negative 1? That happens at pi. Okay? They give us the interval saying just the first time around the unit circle, so those are our 3 answers. Okay? Now, one small problem here. We need to go back in and make sure that this works. Okay? All 3 of these answers work. Because anytime you square, you're introducing additional answers than you had in the beginning. All right, so we need to see if this is indeed true. So what happens if we plug these back in? Let me erase and give us a little space. All right, so cosine of x. The cosine of pi over 2 plus 1 equal to the sine of pi over 2. All right, at pi over 2, the cosine is 0, and the sine of pi over 2 is 1. Bingo, we like that one. How about the cosine of 3 pi over 2 plus 1 equals the sine of 3 pi over 2? Cosine of 3 pi over 2 is 0. The sine of 3 pi over 2 is negative 1. 1 does not equal negative 1. That's an extraneous solution. Let's check the last one. Cosine of pi plus 1 equals the sine of pi. Cosine of pi is going to be negative 1. The sine at pi is 0. That one does check out. So we have one extraneous solution here. See if you can figure out 37 and check for any extraneous solutions. All right, so now we get into some multiple angles here. We've got variables on the inside. All right, so the way we deal with this is exactly the same until the last step. Twist on the last step. So let's add 1. 2 cos 3t equals 1. Cos 3t equals 1/2. So 3t. Where are all the places on the unit circle where the cosine is equal to 1/2? The answer to that is going to be at pi over 3 and also at 5 pi over 3. Oops. Pi over 3 or 5 pi over 3. And I gave us a little space here because remember what we have to do. We have to write plus 2 pi n plus 2 pi n so that we can go around the circle as many times as we want. All right, and we should be done except for this 3 is still there. Let's divide it by 3 everywhere, okay, to get it by itself. So t is equal to pi over 9 plus 2 pi n over 3 or 5 pi over 9 plus 2 pi n over 3. All right, so we just divide by 3 on that last step to get our final answer. All right, so try that one extra step here on 39. All right, so now we're going the opposite way, exact same steps, but we're going to multiply by 2 on our last step, as you can see here. So let's add 3 first. Let's divide by 3. And so now we say tan x, where is tan equal to negative 1? We look around our unit circle for when the x's and the y's are the exact same thing. And we're going to have solutions at 3 pi over 4. That's the only place. Plus, remember it's tangent, so pi n. All right, is our solution. How do we get rid of this 2? We need to multiply everything by 2. So our final answer is x equals 3 pi over 2 plus 2 pi n. All right, so that's our final solution. Getting close. 2 more to try. Try problem 43. See if you can get x by itself. All right, last one here. Example 9, using our inverse function. So example 9 is going to be the only one where we don't have to use the unit circle, because we are going to have things that work. They're just not on the unit circle. So let's see what I mean by that. First things first, secant squared and tangent. That's not going to work. Secant squared, we can change that into 1 plus tangent squared using our Pythagorean. Then we have our minus 2 tan. Let's bring the 4 over. And let's clean this up. Tan squared minus 2 tan x. And minus 4 plus 1 is a minus 3. And so on this one, we've got tan x, we're going to factor it. We're going to have a 3 and a 1, and the 3 would be negative, the 1 would be positive. So tan equals negative 1. Now that is on the unit circle, all right? So that's going to be pi over 4 with a negative. Okay. Or you could say 7 pi over 4. That's another way of looking at your unit circle. 7 pi over 4 is perfectly fine. Okay, that's probably a better answer. Okay, we're more familiar with the positive answers. At 7 pi over 4, tangent has a negative answer, and actually it would also be in quadrant 2, 3 pi over 4, and we're going to have to put a plus pi n on this. Okay, so 3 pi over 4 plus pi n, perfectly fine. Next, though, we're going to have to do the 3. Tan x equals 3. That's not going to be found anywhere on our unit circle. So the best we can do here is say that x is equal to the inverse tan of 3. Perfectly fine to say that. Right? Don't forget to put your plus pi n on the end. 2 solutions. Your job here is done. Try exercise 63 and you will be all set to go for 5-3. Good luck.